All right, digestive system. This is the digestive system. Digestion is when we take large things, or is the process of taking something that is large. Think about a hot dog or a hamburger or something like that, and it breaking it down into small enough pieces that our digestive system can push it into the blood. So you're not going to eat a hamburger and the whole hamburger get pushed into your veins and go to your cells. But you can eat a hamburger and your spit and your teeth and your stomach acid and the bacteria in your intestines, all of those things work together so that it can get into your blood, and that can take the sugars and the nutrients and the fats and the oils and all that to your cells. So the digestive system. The beginning of your digestive system, if you kind of think through this, is your mouth. That's where the beginning is. The when of the beginning is, I would argue that it's when you see food or smell food. Your mouth starts filling up with spit. Your digestive system starts, almost if you imagine a really large engine that takes time to kind of ramp up, that process is it starts whenever you see or smell food. So I would say your mouth is the where. The end is your favorite planet, that is Uranus. That is the end of the digestive system. It's your large intestine, rectum, and your anus. And then the purpose of the digestive system is to two things: break down food and absorb nutrients. Those are the two things. Every organ, every tissue, every cell is either breaking down food, absorbing nutrients, or helping something do those other two. So like your esophagus, you'll see your esophagus is actually just transporting the food from your mouth to your stomach, because your stomach isn't that close to your mouth. And so your esophagus is not breaking down food or not really absorbing nutrients. It's just allowing that food to get from one place to the next. And that's kind of like the respiratory system, how most of the respiratory system is just getting the oxygen to the alveoli. And so in the same way, some of the digestive system is doing something similar. But for the most part, your digestive system has to work together to get things done. All the organs of the digestive system are doing one of these two, most of them at least. Breaks down food, absorbs nutrients. And then we get to the mouth. So we talked about this. We've mentioned this before. You talked about this in 6th grade. Digestion begins here. But how? There's physical change. The physical change is like your teeth taking a hamburger and breaking it apart. And that hamburger, when it goes, if it wasn't for spit, if it was just your teeth, it would be the same as like you taking a knife and cutting that hamburger into smaller and smaller and smaller and smaller and smaller pieces. Chemical digestion would be like if you were to take acid and put it on that hamburger and chemically change that hamburger. That hamburger is no longer just it's not a smaller version of a hamburger. It is literally a different chemicals of that hamburger. So I give the example in other classes. If you were to take a Lego, if you put like 4 or 5 Legos together, and let's say you took those pieces apart. So you had like a little column, you take the little 2x2 Lego pieces and you make a column of them. If you were to take those pieces apart, that is physical change. That is a physical form of digestion when you're just breaking it into smaller pieces. And that's an important part, because the chemical digestion would be like if I were to take acid and pour it on those Legos, and those Legos were to dissolve. Now, you're not going to be able to reform those Legos back together, because those Legos, or if you burn the Legos, you're not going to be able to put them back, because those Legos have changed shape, definitely. They've also changed their chemical makeup. Their chemical makeup is different. And surface area. You talked about surface area in math class, correct? So, surface area, imagine you were to put 4 or 5 Legos together, or and in another stack, you took those same size Legos and you put them and you separated them. If you were to paint the area of the Legos that are in a stick or column, or the Legos that are all separate, which one would take more paint? The Legos that are in the stick together, or the ones that are separate? Which one would take more paint? Yeah, the ones that are separate is going to take more paint. Because if you think about it, when they're all together, there's parts of the Legos that aren't going to be getting paint. In the same way, if your teeth are digesting things physically, or breaking things down physically, and then your spit is breaking them down chemically. And so it's easier for the chemical digestion to happen, kind of like it's easier to cover all the different parts of the Lego if they're separated versus if they're together. You can only paint so much. So the more surface area there is, the more of that saliva it can touch. That's why if you take a pill, if you've ever taken a medicine, like a solid pill or the white pills, if you swallow them and they go into your stomach has to break it down. It's going to take some time for that pill to slowly dissolve and get absorbed into your blood. But some of you I remember my dad always taking the goodie powders, or a powder that's like that. And what it is essentially is it's that same medicine, but it's in powder form that's not been made into a pill. And you actually have to take it. It's almost like pixie stick powder. It's very fine powder, and you have to take it and you swallow it, and it goes down, and it gets into your bloodstream really, really fast. Because remember, talk about digestive system does what? Two things: breaks down food and absorbs nutrients. And if you just if you physically broke it down before you even swallowed it, there's not a whole lot of absorbing that. I mean, there's not a whole lot of more of breaking down that has to happen. It just gets absorbed into the digestive system, into the blood. So a pill has to break down and then it gets absorbed. The powder is already broken down, and so it just needs to get absorbed. Same thing with liquid. A lot of times liquid pills can take effect really, really fast as well. What's an even faster way? Think about other body systems. What's an even faster way for a medicine to take effect? Let's just skip the digestive system all completely. How would you get it into your body?
A shot?
Yeah, a shot, intravenously. You're actually going to get an IV or a shot and directly put that in. So if your throat is starting to close up because you're in anaphylactic shock, because you've something allergic, a bee sting, peanuts, something, your throat is is swelling up and you can't breathe, you don't take a pill for that. What you do is you get an EpiPen and you stab your leg, generally, and you put that shot in there, and it puts adrenaline or epinephrine into your blood immediately. It doesn't have to go through the digestive system. It definitely doesn't even have to break down. So you're skipping breakdown and absorb to just go straight into the blood. And then the tongue sends the food to the next system, next section of the body. And we'll talk about that in just a second. So, if you look in this video, you can see that it says pineapple juice. It says that's what they're drinking. So you've got pineapple juice going down. You can see there's one tube. In the front here, this is we called it the trachea in the respiratory system. It is your larynx, pharynx, and trachea. We just simplify that because you don't have to know all the different parts as your trachea. But this is your windpipe. You think of it as your windpipe. That's in the front. Behind that is the esophagus. Can y'all see it there? Not where the arrow is, but can y'all see the food going down? Is it going down the front one or the back one? The one on the left or one on the right? It's going the one on the right. So here's the question. If you're breathing and that goes down to your lungs, what keeps food and liquid especially from getting into your lungs? And the answer is this thing called the epiglottis. It's called the epiglottis. And you can kind of see it. There's a little fold, like a little flap. And imagine if I have a cup here, and there's a tube coming down, one tube, and it splits into air, and it splits into liquids and foods go to your stomach. One goes to your lungs, one goes to your stomach. You do not want water and food in your lungs. So what happens is, as food gets closer, and you can see it in the video, as food gets closer, the epiglottis, the little flap, it flaps down so that the food can't go down that pipe, down your windpipe, down to your lungs. And then whenever there's no food there, the muscles relax right there, and the epiglottis kind of moves up. Moves down when there's liquid and food, and moves up when there's not. So if you've experienced this before, I think, when you're drinking water a lot at one time, and you're drinking a lot of water, and you kind of have a little bitty cough, and you cough just a little bit. So your epiglottis is covering the wind tube, your windpipe, the trachea, larynx, pharynx, it's covering that. And then you cough a little bit. What's going to happen to that little seal? It's going to open just ever so slightly. It's not that big of a deal. But when that happens, you are now letting water into your lungs, and your body takes over and says, all right, dummy, you're going to let this happen. We're going to make you look like a fool. Because you know what happens next, right? It is a violent, embarrassing cough. And water goes everywhere. It may come out your nose. It may come out your mouth. It just has to come out somewhere. And you do not look cool. You never, after that fact, think, man, I just look so cool. I bet they're really impressed with how I did that. You always look foolish. But your body is making sure that liquid and food don't get into your lungs. That's a bad thing. So the epiglottis is there that covers, and you can see that in the video, the little snapshot. You can see there's you see a little fold right here, and you can see a little bit of one, I think, on the left there. My arrow's messing up. And you can feel this in your throat. You feel your throat, put your finger to your throat, and swallow. You can see how it kind of moves up and in. Do y'all feel that? Your epiglottis is covering that valve. And next time you cough, I want you to think about Mr. Hurley. And remember, you don't look cool. You need to figure out how to eat and drink and breathe in between those things, because you can't do both at the same time. So that's the esophagus. That's where the food starts going down. And it goes down all the way down. What is this organ? Your stomach. And there's a sphincter here. Now remember, a sphincter is made out of smooth muscle. It's not cardiac. It's not skeletal. A sphincter examples are the LES, the lower esophageal sphincter. There's another one at the bottom of the stomach that's called the pyloric sphincter. And you have one at the bottom of your bladder. You have one at the bottom of your large intestine. Like your anus is an example of a sphincter. Now that word is sphincter. I believe you spell it S-P-H-I-N-C-T-E-R, sphincter. It's close enough. I like that word. It just sounds cool. It sounds weird. Sphincter. Everybody say it. Sphincter. So your sphincter is soft tissue that squeezes, that is essentially squeezing some kind of tube. So you're like a water hose. If you were to put a zip tie so tight around a water hose that the water couldn't go through, that's kind of like a sphincter. It's functioning like a sphincter. This is why if you drink soup or eat some soup for lunch or dinner, and you go turn upside down on the handlebars, the food doesn't just come out of your mouth, because you have a sphincter at the top that is squeezing to make sure it doesn't. The same thing at the bottom. We'll talk about this in a second, but the sphincter is also protecting the small intestine from all the acid that is in your stomach. All right, so the esophagus. It's the tube or the tunnel that connects the stomach and the mouth. This is an example. This is one that's supporting the other two. Muscles move the food. So already in this, you can see that we've got different tissues that cover this, that seal the larynx, pharynx, and trachea, that windpipe. You've got tissues that are moving the food down, the muscles that are in the esophagus. You've got the what did I call it? The sphincter, the lower esophageal sphincter. That's right here. You've got different types of tissues that are working for just the esophagus. Go ahead and write down, take notes on esophagus, and then we'll move to the stomach. All right, let's get to the stomach. The stomach. So the stomach, its main job is going to be to break down food. How does it break down food? There's a chemical that's in the stomach. What is it called? Acid. It is acid. It is stomach acid. Now, this is not enough acid where if you were to, I know my sister used to take like the ramen noodles, and she would have a really, really long string of pasta, and she would swallow all the noodle, hold on to the end, and then pull it all the way back out. And I used to think, man, you could like, you know, if a bad guy came in, you could do that and throw it on and they would die. Like that's not what's going to happen. That acid is very strong, and it can dissolve meat, and we're made of meat, so it can be harmful. But it's not going to like eat through your arm if you touch it to your arm. Now it can cause some chemical burns if there's a lot of it and it has time to sit there. You'll talk about acids and bases next year, but an acid can be neutralized by a base. So water is a 7 on the pH scale. And it goes from 1 to 14, so 7 is in the middle. Water is neutral. Is neutral. If you have a base that is 1 away from neutral and an acid that is 1 away from neutral, it's kind of like the number line, right? -1 and a 1 equal neutral. So the stronger the acid, the more destructive, and the stronger the base, the more destructive. But if you get one that's on the opposite end of the scale, they kind of neutralize out. And we'll talk about that in just a sec when it talks about some of the other organs in this body system. But yeah, so acid starts to break down food. So I don't know if you know this, but hot dogs are made of a bunch of different organs in animals. I don't know if we've talked about this, but hot dogs can be made of pig stomachs, and pig, cow, and chicken stomachs, intestines, soft tissue that's in them, smooth muscle, all kinds of different stuff inside the sphincters that animals are made of. It's all the stuff that's like the higher level meat. We generally, our culture generally sees like steaks and skeletal muscles as the highest, and cardiac muscle is kind of a weird thing to eat, and the smooth muscles are kind of like they're not as valuable, because like if I had a hot dog and a steak, we're not going to pay the same amount for those two things. That's just generally not how that's going to happen. Regardless of your preference as a society, that's just generally what we do. But if you'll notice, So my point of saying that is a hot dog. If you eat a hot dog, you're essentially eating a stomach, right? Like you may be eating an animal stomach. So here's the question. If your stomach acid in the stomach can break down stomach, like a cow or whatever, why can't the stomach acid in your stomach break down your stomach? And so here's the answer. Here's the secret. Because here's some problems. Let's talk about some problems. If you have heartburn, that means stomach acid is coming up into your esophagus. Has nothing to do with your heart. It's just in your chest up there. Has acid is starting to come up into your esophagus, and I think it normally has to do with this sphincter right here that's opening up, and it's breaking that down. Or this pyloric sphincter can be letting too much acid down into the small intestine, and that can cause problems. Or you can have a stomach ulcer, and the acid is actually eating away at the lining of your stomach. And all of these things can be very, very damaging. I'm pretty sure stomach ulcers can kill you. If Dumb and Dumber has taught me anything, that's true. But so you have mucosa. What does that sound like? Mucus. And then you have the submucosa, and then you have muscle and the serosa. I don't really know what the serosa is doing. I'm guessing that's just the outer lining of the stomach, but I'm not sure. But mucus, your stomach is actually producing a mucus that is protecting your stomach from the acid. Does that make sense? It's like whenever I'm fighting and wrestling with little kids, like at church or my nephews and nieces, don't look at me like I'm not doing that because that makes me feel big and bad. I'm saying I'm doing that because I'm playing with them. But whenever I'm doing that, like, and they're playing magic and they're doing something, I pretend I have a force field up. I say my force field is way stronger than your magic, and your magic darts can't come through my force field. And typically that ends in them being really sad. Which is really funny. But that's essentially what's happening. This acid in here, in the stomach, is breaking down food, whether that's meat or vegetables or whatever. It's breaking down food, and the mucus of the stomach, of the lining of the stomach, is actually stopping that acid from breaking itself down. Does that make sense? And it has to continually make mucus. If it doesn't or something goes wrong, then that part of the stomach can start getting digested. That's kind of a big deal if your stomach itself is being digested. That's not really good. So again, the stomach is breaking down food, and the main way that it does that, the primary way it does that is going to be through acid, but it's also absorbing liquids, absorbing nutrients, absorbing substances. So somebody who drinks alcohol, I believe that alcohol is being absorbed through the stomach. If you take medicine and it's fast acting, my understanding is that it is absorbed into in the stomach. Where is it sent to? From the stomach into? No, not into the small intestines. To your blood, to the circulatory system. Because all around the stomach, and this picture doesn't show it, but all around the stomach there are blood vessels, like around the alveoli. It is moving, it's not doing the same thing, but it is moving things into the bloodstream. So again, you don't have to memorize these sphincters. I just want you to understand, there's the muscular system right there. A lower esophageal sphincter, pyloric sphincter, things like that. Go ahead and write about the stomach in your notes. All right, so we got some more animations. This little purple thing that's coming down is called the bolus. Imagine it's like a ball. I think that's what bolus means. It's a ball that's coming down the esophagus into your stomach. It pops through that sphincter. The stomach is actually looks like it's kind of milking itself, right? Like it's actually moving. Those smooth muscles in the stomach are doing the same thing the esophagus did. And it's doing the same thing that the small intestine will do. Those smooth muscles are squeezing together and relaxing in just the right way so that the fluid, that bolus, the stuff is moved on. All right, pancreas, liver, and gallbladder. And I had a friend, his name is Shocker. He was drinking some water. He took the cap off of the water and he turned it. It's the cheaper caps that are like half a spin and the cap's off the water. He was doing that while he was driving, and as he was doing that, he breathed in, and the cap went down his throat and all but stopped his breathing. So a little bit of air could go through. He ended up, long story short, he ended up trying to cough, and when he did, it went from kind of being diagonal to where some air can go through to going flat and sealing that hole, and he blacked out a couple of times. He got into the hospital. I don't know what the hospital did, but he ended up having to pass that. By pass, I mean he had to poop it out. Had to go through his whole digestive system. And we joked about it, but guys, that little cap that he consumed, that he ate or swallowed, and then he passed, it never went through these three organs. And so in your mind, you should be asking, then why are we having to study this in the digestive system if it's not actually having food go through it? Now remember, every organ in this system either breaks down food, absorbs nutrients, or helps the ones that do. And so the pancreas, you may have heard of the pancreas before. The pancreas makes two. Now, these organs do other things, but here are the main things. And don't take notes yet. But it produces fluid that neutralizes the acid. Remember I talked about earlier? The acid that's in your stomach has to be contrasted or neutralized, and it's neutralized here. Or the chemical is made in the pancreas. Also, the pancreas, kind of a big deal, it makes insulin. So if you've ever heard of diabetes or known somebody that has diabetes, that is made here. Insulin is made here. And so if you can't regulate, remember we talked about there's thousands of ways your body can die every day. And one of those ways is by blood sugar. Another one of those ways is by your acid eating you from the inside out. Like, there's just so many ways. But your body, if it can maintain homeostasis, it's going to be doing things like creating insulin and creating the fluid, the enzymes that neutralize acid. So that's the pancreas, kind of important, kind of a big deal. The liver does a couple different things, but we're just going to mention this one thing. It creates bile. It creates bile. Now, you may have heard of bile before. Maybe when you were throwing up one time, somebody said that you threw that up. I'm not sure if it's actually bile. I've always called it bile. But bile is a chemical that breaks down fats. If you think about fats, if you've ever had somebody cook something and you had to do the dishes later, the stuff that's on the outside that's really thick, it's just, bacon grease. Like there's a fat in your body has to have bile to break that down. If it doesn't, it can't break it down. It has to have bile. Liver creates bile. The gallbladder stores bile. And I believe bile and gall are the same thing. We just call it bile. I'm not sure where that happened. But one makes it, the liver makes it, and the gallbladder stores it right here. And the liver does other stuff too. Liver does other stuff, but one of the jobs for the digestive system that we're going to talk about is it doing this. So I'm going to take those notes on the pancreas, liver, and gallbladder. Briefly say what it is. I just want to point out that the food never goes through these organs. These organs secrete stuff into the next organ we're going to talk about, the small intestine. All right, the small intestines. The small intestine. So I always imagined the small intestine as being like a water hose. It's a smooth inside. The stuff goes through really easily and passes through very easily. That is not what's on the inside of the small intestine. The small intestine looks more like, imagine you take some carpet and you roll it up. And then you have to so if you had a carpet that's rolled up and a big water hose, and you had to push cake batter through one side to the other side, which one is going to be touching the cake batter more, the carpet or the big water hose?
The big water hose.
I would argue that the carpet, because the carpet I don't know if y'all have looked at carpet really closely, like really tall carpet. Carpet has these little pieces of yarn that are like V-shaped. And as the cake batter would go through, it would be touching this yarn. And it's not the best example, but that when I visualize villi, the small intestine, I'm thinking of this right here. So this is a villi, almost like it's a bunch of villains, but that's not what it is. A villi is a very similar part of the organ like an alveoli. Do you remember alveoli? The part that does all the work for the respiratory system? A villi is, instead of the alveolus has blood on the outside, right? The blood vessels are on the outside of the alveoli, taking oxygen back, or sending air back and forth. The villi have blood on the inside, right here. So if you imagine the food going through the small intestines, and by the way, it's 15 feet long, something like 15 feet long. It's a very long. So why would they call it the small intestine? It has nothing to do with its length. It has to do with its diameter. So the diameter of the small intestines is very narrow. It's very small. And the reason is because the food needs to touch the outside of that small intestine all the way through as much as possible. Because if something were to be able to go straight through the middle of the small intestine without touching the walls, it's not going to get absorbed into the blood. So all these little carpet pieces, what are these called? Villi. And we can see here's a picture of them. All these villi also have little pieces on them that are also absorbing nutrients and sugar and poisons. If there's poison in there, it's absorbing stuff through. Remember, this happens through diffusion. You remember talking about diffusion? This is happening through processes similar to it's like diffusion, and it's moving into the blood, gets into the blood, and it goes to the rest of the body. You can see that in the animation here, in the digital media here. It goes through this. Do y'all see these little dots? Can y'all see that?
Yes.
Those are one cell. Each of those is a single cell. So to go from in here where there's food, nutrients is broken down. Think about like sloshy cookie dough, or essentially something like, I hate to say it, but like diarrhea. Imagine something like diarrhea. That's kind of what's going through your small intestine. And the more it touches the walls of your intestines, the more it can be absorbed. So food goes through, it hits these villi. The villi, imagine them kind of sucking up the nutrients and the sugars and all the vitamins, and if there's toxins in there too, gets into the blood. The blood takes it to the rest of the body where they can go through cell respiration because now they have sugar. Here's an kind of digital media of villi. This may make more sense the more you look at it. The small intestines, the main job here, or not the main job, a big job it has is to absorb nutrients. And it's going to be absorbing nutrients through the villi. That's why there's so many pictures of the villi here. The villi are very important in the small intestines. But also very important is there are organisms that live in here. You know what they're called? Extremely, extremely important. Bacteria. These bacteria are not trying to kill you. In fact, without these bacteria, we would not be able to digest a large part of what we eat. If you were to kill all the bacteria on and in your body, we would not be able to live the same if we were able to live at all. We live together, very closely together, and we need each other. And so when we eat food, these bacteria in the intestines actually are breaking down that food for us. So our digestive system, it needs to break it down itself, and it needs to allow organisms to live that can break it down. So bacteria in your body are extremely, extremely, extremely important. We found there's been a lot of research that shows that the more bacteria you have and the wider variety of bacteria you have in your body, the better and the more healthy you are. We can talk about that later if you have questions. And the large intestines, last one. The large intestines. So the small intestines, if you remember, the small intestines is all in this area where there's white, and then it drops and it moves into the large intestines. The large intestines has a very important job. It takes that, what we call like similar to diarrhea, and it absorbs all the water. The large intestines absorbs water. And so if you'll think through this, if you've ever had diarrhea, I know this is a gross thought, but if you've ever had diarrhea, it has got a lot of water. It comes out very, very, very liquidy. The reason that it does is because there's been some kind of bacteria or virus or something's going on in your body. And imagine, and Osmosis Jones will see, imagine there's like a button that somebody hits, one of the cells like, nope, we got to go, bad guys. And the large intestine says, all right, let's go, lickety split, and it pushes all that bowel movement out very quickly. Because it's happening so quickly, the large intestines cannot do its job. And its job is to absorb water. Guys, I listened to a book recently that says something needs to change. This guy named David Platt. He was going to the Himalayas on kind of like a mission trip, and he was talking to a guy. This guy had a 1.5, 2-year-old in his arms, and he was talking to the guy, and through the translator, they figured out this guy's children, he had 3 kids. The other 2 kids died about a year before. You know what they died from? Diarrhea. Those 2 kids and about 58 others, or 60 people in this village, 60 people. Imagine an area, a school maybe the size of Pine Grove and Middle and Pine Grove Elementary, and 60 of us dying from diarrhea within about a week's time. We're talking everybody's healthy in a few hours. A lot of people have cholera, which is what it was, and then a week later, 60 people are dead because they don't have clean drinking water and they don't have very easy medicine medicine that's very available to us, but it's not to them. Guys, people die of diarrhea all the time. It is a very dangerous thing, but we live in a country, in a society that it's easy to get clean water. I mean, even if you have nasty smelling water, it's still clean water. It doesn't have cryptosporidium or giardia or things like cholera. It doesn't have those things that are going to give you diarrhea. Diarrhea is deadly. We just can fight it very easily by drinking a lot of good water and having a little bit of good medicine. So remember that next time when you're complaining about being sick about something, realize that majority of the time when we're sick, it is not life-threatening. It is, hey, I just have to be out of school for a couple of days and make up work, or I can't go play, or I can't go to do this activity or whatever. But your large intestines, its main job is to absorb water. It absorbs water. Unless you're sick, and then it just pushes it through, and that's what diarrhea is. So go ahead and take notes on this, and then we'll do our reflections.